Hey everyone, ever wondered why the prices of tomatoes suddenly jump overnight? Or how farmers decide when and where to sell their produce? Behind these everyday choices lies a storm of data that often goes unnoticed.
We have developed a system that predicts the future prices of agriculture commodities like pulses based on past data. Farmers often face difficulties in knowing the market price of their produce. Usually don't receive the fair value for their crops, primarily due to the lack of real-time price information.
So, to address this challenge, we propose a smart prediction system that uses machine learning to forecast the future prices of the agricultural commodities based on factors such as historical trends, commodity type, and the location of the crop. The system provides an estimated price of a particular crop so that it would be helpful for the farmers and the stakeholders to plan their selling strategy more effectively.
We collected our data from official government sources like AgMarkNet and other public agriculture price portals because it contains monthly prices of various agricultural commodities across different states of India starting from 2014 to the most recent months available.
It includes important features like commodity name, state, and month-wise average prices, which we carefully clean and transform into a time series format. This historical price data is what powers our prediction model, enabling us to predict future prices based on past trends.
Front-end part was taken over by me. Let me quickly introduce you to Streamlit. It's an amazing Python library that lets you create interactive web apps without any web development experiences. Streamlit is super simple. You just write a Python code like you normally would. Streamlit turns into a clean web app. To add sliders, buttons or charts, just one line of code.
The model testing and training was taken over by me. Once the data was ready, we combine all the features into a single data frame and then split it into training and testing sets. I applied min-max scaling to numerical columns and label encoding to categorical columns. For prediction, I tried out different machine learning models such as multiple linear regression using stats model, decision tree regressor, and random forest regressor. Out of the models that I tried out, the random forest regressor has given better R2 score and lower error values. We use metrics such as mean squared error, root mean squared error, and R2 score to evaluate the performance of the model. Finalizing the model, I saved it using Joblib so that it would be useful in the future in our Streamlit app to make real-world predictions. We also created some visualizations like bar chart, scatter plot, and correlation plot to better understand the data distribution and relationship between features. So, after comparing multiple models, we selected random forest regressor as our final model as it gave us most accurate and reliable results.
Let's move to the demo of our project and see how a user can interact with our prediction system.
So before starting the demo, let me just quickly show you our front-end code that we have written in Streamlit. So there's the code and the data we have collected. It contains several features like the year, the month, the arrival, the min price, max price, and the district name and the state name also. And this is our model that we have trained. Like we have pre-processed the data, we split it into training and testing splits, and then we trained it. And these are the visualizations like the bar chart, the correlation plot. So hi guys, welcome back. Let me just give you a quick demo of our product, first price. Okay, the main page contains the about the project section where you can find the details of a project and the main motivation to build this project. It also contains the key features that we have implemented in this project. There are also sections where you can check whether the ML model and the CSV data have been successfully loaded or not. Now, as we can see, the ML model and the CSV data have been successfully loaded in our page. So yeah, let's proceed. Yeah, here the user can select the commodity that he wants to predict the price of. So let me just select potato for you guys, and then in this place the user can select the place or the location where he wants to predict the future prices. Let me just select Mumbai. Would be nice. And there is also a date selection where the user can select future date of which he wants to predict prices. Okay, let me show you this. It will just take some time to load the model and run it. So yeah, it's ready. Let's click generate forecast, and now it will take time and predict price based on the past trends. So yeah, here we can see the commodity we selected, the location we selected, and the date we want to predict the price. We got the predicted prices at 31 rupees. and also we have the date on which we have predicted the prices. Here there is a section that shows us the predicted price, and here we have the price trend forecast graph. The green solid line shows the historical prices, that is our actual data, and the yellow dashed line shows the future prices that our model has predicted, and the red vertical line here is where the actual prediction is started, like the date the user has selected above. And this visualization helps users understand not only the trends from the past data, but also gives a clear picture of where the prices might lead in the near future. And below our forecast graph, we also display the root mean square error. This metric tells us how accurate our predictions are. So yeah, that's a quick demo from my side, guys. Thank you for your time.